So, requesting the audience to please settle down. We will begin the program in 5 minutes. Thank you.
kamighimo tolangit sikoy ko kamighimo to aldo way bulan ikaw ang nagbuhat sa kabituunan ikaw ang nagbuhat sa kalibutan manama mawantog ka warag po ko ilingkoy ko o Diyos kahibulungan ka busa ikaw lang ang simbahon ko
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم فقال ربكم ادعوني أستجب لكم آمين يا رب العالمين الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين آمين اللهم اجمع شامل المسلمين والكريستيان والرومان في مدينة دباو وسلم دائما مجتمعنا هذا بالسلم والأمن والتقدم في بلدنا هذا آمين يا رب العالمين ربنا لا تزغ قلوبنا بعد إذ هديتنا وهب لنا من لدنك رحمة إنك أنت الوهاب ربنا إنك أنت الوهاب ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار وصلى الله على خير خلقه سيدنا محمد وعلى آله وصحبه وسلم سبحان ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين آمين يا رب العالمين.
In the name of the Father, Son, and Holy Spirit. Amen. Our most gracious Heavenly Father, we come to you today to praise and worship you and give you thanks for all the things you continue to provide for ourselves and our families. Father, we humbly ask for forgiveness for all the times we have offended you, when we forget to acknowledge your presence in the image of our brothers and sisters, and for moments we fail to be good stewards of the blessings you have given us. Continue to guide and protect each one of us, Lord, that we may always walk in the lights of your everlasting love and mercy. Grant us, Father, with your comfort in times of distress and with your strength in times of weakness. Bestow upon us your unending grace and healing, that we may in turn become instruments of gentleness and compassion to others. We ask all this in the name of your Son, our Lord Jesus Christ, with the prayer and the intercession of our Blessed Mother. Amen.
manama mawantog ka warag po ko ilingkoy ko o Diyos kahibulungan ka busa ikaw lang ang simbahon ko busa
kababayan, ang pambansang awit ng Pilipinas. Kayang magiliw, telas ng sinangalan, alam ng puso, sa dikit mo'y buhay. Lupang hinirang, kuya ka ng magiting, sa manluluping, di ka pasisingil, sa nagatak tutok sa simoy at sa langit mong pagaw, ay dinatang tulang awit sa pagkayang minamahal. Ang isang ng matawag mo'y tagumpay na nagtitindig, ang bituin at araw niya kailan pa may di magtitindig. Lumalang araw ng walhaging pagsinta, buhay langit sa piling mo. Ang inigaya ng pagkay mga amin, ang mamatay ng dahil sa'yo.
So, hello everyone! Welcome to our second session for today's JPIChE Atelier. I hope everyone had the time to eat their lunch and took their rest during the break.
Hello and good afternoon, participants. So, to those who are with us in our Caltech webinar session this morning, thank you for coming back. And to those who just joined us today, welcome and thank you so much for coming. So once again, I am Math Hilary Pagantalan. You can call me Math.
And I am Ray Anthony F. Comia, and you can call me Ray. And we are your hosts for today.
You know, partner, I am very happy right now because I can see that there are participants coming from various schools.
Yes.
Yes, partner. So it is heartwarming seeing people who are interested in joining your event. So with that, thank you so much for giving your time and effort by joining this webinar. So thank you.
I agree, Math. So with that, it is only fitting that we acknowledge the presence of our participants. So let us see some signs of life from our participants. So if your university is called, you may use the Zoom Reacts or the Zoom chat box so that we can see and hear from you guys. So yeah, okay, can we hear from, are there people from Ateneo de Davao University? Do. Let's see. I see. Hello.
Hello.
So I think there are, maybe they're busy right now. They have classes now.
Yes.
So,
yes, partner. Wow, amazing. So how about from the Mindanao State University main campus? So, wow.
from our most active
MSU,
participants,
yes,
MSU Main.
Wow, amazing. From Sheen to
Hello,
to
Neil.
France. So hello.
France.
Thank you for coming,
So
guys.
hello to all of you. And of course, let's make some noise from the Xavier University Ateneo de Cagayan.
Go XU.
Let's go, XU. Hello everyone. So for those na hindi pa na-mention, kindly mention your school or your university in our chat box or comment section so that you will be recognized. So what school are you from? For the other students here in our Zoom today.
I think we have from the MSC. Am I
Oh,
right? MSC.
Yeah. From Marinduque State College, right?
Yes, I think. And RSU.
Yeah, Rizal State U. They're
Yes.
all from Luzon,
Yes.
I think. So yun, I think we've heard from everyone already. Let's just maintain that kind of energy, people, because this afternoon will surely be fruitful and fun.
Of course. But before we formally start our program, let us thank our event partners first. So this event would not be possible without our event partners. So we would like to thank Aim to Top Philippines Review Center for being one of our sponsors. Aim to Top Philippines provides intensive preparation for both local and foreign qualifying exams.
Yes, we would also like to thank Project Ink Print Shop for partnering with us. Project Ink Print Shop, print it the way you want it. Again, thank you so much, Aim to Top Philippines Review Center and Project Ink Print Shop for sponsoring this event. Thank you, thank you.
Thank you to all our partners. No? But before we proceed to our webinar, let us be reminded of these 3 Ds. So first, be respectful. When not, sure that you are on mute to avoid any disturbances during the speaker's talk. When someone else talking, do not overlap by talking at the same time. Second, be attentive. Listen well to the topics being discussed by the speaker. When another person is talking, listen. The third is be participative. When the speaker asks a question, answer by chatting in the chat box or turning on your mic. The questions will be entertained during the Q&A portions. So there will be a 25-minute Q&A portion after the talk. So kindly hold on to your questions while the talk is ongoing. So.
Yes, all right, partner. For this afternoon session, we will be having the Excel VBA webinar. As a chemical engineering student, I know that Excel can help in solving some of our lengthy solutions, may it be for problem sets or quizzes. So, in this juncture, let us introduce our speaker. So, introduction of our speaker, he is currently an on-site operations engineer at Linde, involved in the operation of air separation and steam methane reforming plants. Previously, he spent 2 years in the process design and simulation of waste to energy and environmental processes in both Malaysia and China. He is an avid user of VBA for automation, data analytics, and process calculations. Wei Jian's achievement include selected as the Digital Transformation Task Force in Linde and being certified in Google Cloud Big Data and Machine Learning Fundamentals. So yeah, let us all welcome Engineer Wei Jian Teo.
Hi, thank you, Wei. Thank you, Xavier, for the very, very kind introduction. And welcome to everyone from the Philippines. As my name is Wei Jian, you can just call me Jian if you want. And I'm a Malaysian, so I'm from Malaysia in case were wondering. So if I'm able to, can I take over the screen now?
Yes, sir.
Thank you. So just let me know, everyone, just let me know if you can see and hear me well, and also see myself by typing a 1 in the chat box. Let me know by typing a 1 in the chat box that you can see my slides and hear me well. Yeah. Okay, I'm seeing lots and lots of ones in the chat. All right, so everyone's not asleep today. So welcome everyone. So I'm not going to take any more of your time, and let's jump into our topic for today, which is about Excel VBA programming. All right, so a little bit about myself. Before that, a little bit about today's presentation. I'll be talking a bit about myself, some common myths about chemical engineering students and VBA, the basic syntax of VBA, and some hands-on examples. So I'm going to introduce you to my friend, my virtual friend Steve, who is going to be a chemical engineering student that's going to be learning about VBA as well, together with us. All right. So a little bit about myself. I consider myself one of a coffee enthusiast and part-time engineer. And previously I did launch a YouTube channel called JPIChE which is a YouTube channel where you can learn about VBA and Python in chemical engineering applications. I previously was involved in UniChat, which is an app that you can download from Google Play and App Store. Currently, it's only for Malaysians, unfortunately, but there are plans of expanding it to the Philippines and Singapore and neighboring countries. And you can meet the rest of yourself. My interests are in AI, coding, and simulation, and also some automation, mainly because I'm too lazy to do everything manually. So I always think of simple ways of doing things and not the manual ways of doing things. My hobbies are posting on LinkedIn. So some of you have connected with me on LinkedIn. I'm thankful for that. If not, then well, feel free to just search my name on LinkedIn to find it. Having coffee. I'm always having a coffee all the time. And some cool FPS and RTS games. Yeah, so that's my interest. So I have 15 years of coding experience. That's unbelievable, right? So if you are, in case you don't know, I'm in Malaysia called Penang. And on this island is famous for its food. And usually we have arguments with Singaporeans about who owns which food. For example, chicken rice, is it Malaysian or Singaporean? And then the flame wars on the internet are never ending about chicken rice is Malaysian or Singaporean. And then the Chinese come in and say it's theirs, and then we start fighting each other. So food is a big thing in Malaysia and Singapore. So my first experience with coding was when this floating bookstore called MB Dollars dock in Penang. And it's actually a sort of a bookstore that travels around the world like a ship. And I bought this book called HTML Complete released in 1997. And this book, this price here is $25 US, but I actually bought it for like 25 ringgit, which is like $5 US. So that was how I started to coding, and that actually raised my interest in coding and stuff like that. So your question might be, who the heck reads books like this nowadays? We have YouTube, right? Well, YouTube was created in 2004. I bought this book in 2003. So that's why I still read books. Unlike you guys, I don't think you guys read books like this anymore. And honestly, I don't think MV Dollars even exists. I think they decommissioned the ship after like 10 years of the voyage. So with this, with the knowledge I gained from this book, I actually created my own website in 2003 called Vacation. Websites are done with dial-up connections. I'm not sure if you guys know what is a dial-up connection nowadays, where when you have to log into the internet, you have to wait like 30 seconds, and there will be a very funny dial tone. It's like it's like a song if you can imagine that. And at the time, my website was limited to 5 megabytes of space and encoded with HTML 4.0. Unfortunately, I did not pay the hosting fee, and they took it down after that. So we can't watch it anymore. Otherwise, probably there are some like good places in Malaysia for vacation that you could actually look from the website. Unfortunately, it's down now, and I have no plans to actually put it up because I couldn't afford the fee to continue hosting it. So the language that I learned was HTML 4.0, which has now been superseded by HTML 5.0. And nowadays, you can find a lot of this information. If you want to create your own website, you can learn HTML 5.0. But today, I'm not here about creating websites, even though I started my coding journey in creating websites. So this was in 2011, where I actually won a website design competition in part of the Scouts Association. So this is me on the left side, and on the right side is my friend, Andrew, who is a software engineer in Amazon now in the US. So both of us have ended in very, very different places, but I'm sure he's doing well in his own right. And this was my website at that time. And it was just talking about natural disasters and how we can protect ourselves from them. So a little bit about my university life. I see almost all of you are students. So my first share a little bit of what I do. So I was very lucky to be able to visit an offshore oil rig, the Malikai Oil Rig project in East Malaysia. I joined the National Chemical Engineering Symposium, which is like a gathering of chemical engineering students in Malaysia. I was part of the app development team for UniChat, which was the app that I talked about. You can search for it on the App Store, or Apple App Store, or Google Play. I was the head of the IUM Disrupt, which is a 24-hour hackathon. I was the director for the Regional Chemical Engineering Undergraduate Conference. And I also, just to balance it out, I also joined cultural events like a Chinese literature competition out of that. And this was how I actually got interested in programming. The UniChat app, which the 4 founders are on the screen now, and they invited me to be in their team. So it has 10,000 downloads and about 5,000 active users in Malaysia. So have a look. But unfortunately, I don't think it works in the Philippines. So yeah, that's something that we are looking at in the future. So what do I do now? All this talk about web design and app programming and such. So now I'm a fully fledged chemical engineer. So I run a chemical engineering group on Facebook and Telegram. So if you're interested to join, feel free to just click on the link in the chat box, and you can have into our community as well. All right. So I also frequently run my YouTube channel. So I post stuff about Python, VBA, solver, GoSig, and things like that. I also frequently post on LinkedIn about some tips and tricks that you can do on Python, VBA, and stuff about chemical engineering. It's something that I just do for fun. And also another way is it's a way of me giving back to the chemical engineering community, because in university, nobody told me that these things were important. And when I come out to work, I realized them. So now I'm telling you that they are important. So please make sure that you equip yourself with the skills required in the chemical engineering industry nowadays. So before we go into the VBA part of Excel VBA, I'm sure you know what the Excel part is, right? Microsoft Excel is a spreadsheet program. And Microsoft Excel is mainly designed for people in accounting, finance, statistics, and so on. Or that would be the impression that you get when you open Microsoft Excel. But the fact is that many engineers do use Microsoft Excel. In fact, every engineer uses Microsoft Excel. And there are many features in it that we are still exploring. And many people don't know. So at least you probably know what Excel is. If you are not using this version, which is 2016, your screen will look a bit different. But to me, it's the same. All right. So there are some common myths about that I would like to dispel before we start the real topic of today. The first is that some people think Excel is just for accountants, mathematicians, and so on. But in fact, engineers use Excel almost every day. Almost every day. Programming is only for computer science students. In fact, engineers do use programming, even chemical engineers, even though it might sound very far-fetched, but it's true. Programming is only for nerds. Now, that's a very big misconception. In fact, programming is cool nowadays. If you know programming, you are the cool guys now. It's now the opposite. And finally, you need special software for programming. It's very difficult. The fact is that you can do programming in Excel, you can do programming in Notepad, in Microsoft Word, even in PowerPoint. But I don't see any reason for doing that, but you could do programming in PowerPoint if you wanted to. All right. And when it comes to programming, you go and do a Google search on programming, there are tons of results. There are tons of programming languages. So where do we start? Now that's a very important question, right? When it comes to learning about programming. So the most famous nowadays would be R and Spark, which are very common when very commonly shared by people who are in the data science community. So R is something that is used in data science and machine learning, usually paired with the tool we call RStudio. So that's what it is. If you join those events like Google, Amazon, IBM, and so on, we talk a lot about RStudio as a statistical package for machine learning and data science. MATLAB and Octave are something that you probably learned in university. They are specialized engineering software. Although fundamentally, MATLAB is designed for signal processing, electrical engineering applications. Octave is the open source version of MATLAB, which nobody told me existed until I graduated from university. So that's one thing that I would like to point out. So if you don't have a MATLAB license, which can be very expensive, just go ahead and download Octave. It's a very small installation. It's 100 megabytes. You can run it on any computer. Yeah. Yeah, Java and JavaScript are used for app development. There are some other developments from these two languages that are quite famous. For example, React Native for Apple app development. We have JSON for server-side development and so on, but I don't want to go too much into that. And we also have HTML, XML. They are used for website design applications. And in a very strict sense of programming, they are programming languages, but they are a subset of programming that we call markup languages. Right. So the question today is, where's VBA? I think the keen-eyed people in the audience will notice that VBA is actually part of this table. It's just not obvious. So VBA actually stands for Visual Basic for Applications. Visual Basic VB for Applications A. And Visual Basic is the programming language used to write Microsoft Windows and all Windows applications. So when you turn on a computer, the Windows logo shows up. That's VBA. So Microsoft actually packaged the Visual Basic into a specialized format for use in certain applications like Microsoft Office. And then that version of Visual Basic is called Visual Basic for Applications. So the for applications part means for Microsoft Office, for Excel, Word, and so on. And the most powerful part when integrating VBA into your Excel is it allows for user-defined functions. This can be said to be the most important part of learning VBA, which is that you can define your own functions inside Excel. And that's what I'm going to show you in the next few slides. The more programming-oriented people might ask, is VBA an object-oriented programming language? The answer is yes. But if you don't know what an object-oriented programming language is, then don't worry, because you probably don't need to know. It's more of a deeper programming concept. But to put it simply, it means that you can define your own classes and your own objects in the language itself. So when do we use VBA? Sounds great, right? It sounds powerful, but when do we use it? We don't use it when we can solve these problems via simple Excel formulas, via GoSig, and via Solver. So GoSig and Solver are add-ins in Excel that you can use for solving equations. So that's easier to do than using VBA. But VBA has its strengths when it comes to repetitive tasks, complicated tasks, and also iterative tasks. So I'm going to show you what I mean by repetitive, complicated, and iterative in the next few slides. So before we continue, I would like everyone here to download a copy of the worksheet from the link below, which I'm going to post in the chat for your convenience. And if you manage to download the worksheet, right, please let me know in the chat, just so I can make sure everyone's following. So this Excel worksheet is going to contain some examples that, because of the time constraints of this workshop, I'm going to make it simple for you. I'm going to prepare some examples so that you don't have to write them from scratch, and you can jump in immediately. So one thing that I would like to say is that VBA is something that is best learned by doing, not by listening. So if you are interested to really master VBA, it's best that if you can try it out using your own Microsoft Excel, which I'm sure everyone has. And if you try it out, right, you can master in 2 hours, 3 hours. Okay, so I'm seeing a lot of people, a few dance in the chat, so I'm assuming that everyone has the worksheet now. So let's proceed with our workshop. So how do we do VBA programming in Microsoft Excel? You might ask me, like, I have never seen any way of doing it in Microsoft Excel. How do I do it? The answer is by using an IDE. IDE stands for Integrated Development Environment. So basically, it's where you put all your code you run your code and you modify your code inside this IDE. So you might be asking, I've never seen this screen before in my Excel. How do I do that? So there are 4 components of VBA, just 4 components. Don't make it too complicated for yourself. There are only 4 components that you need to know in order to know how to use VBA. The first is you need to import or save certain pieces of information, and that is done inside variables. So a variable is where you store information, and it acts as a temporary container for information. After you have this information, what you do is you manipulate this information. You either do mathematical operations on it, like addition, delete, subtraction, multiplication, and so on. Or you can modify it other ways. For example, you might want to join them, you might want to detach them or something like that. You do that with what we call operators. Once you have the information, once we know how to manipulate them, it is now to run it in a sort of sequence. So I want some information to be manipulated under a certain condition. So that will be a branching. Or I want this information to be manipulated multiple times. So that will be a loop. And finally, I will package all the first 3 components into what we call a sequence of operations. Or in VBA, we call them functions or subs. So that's it. That's VBA in a nutshell. All right. So let's not jump in too fast, and let's go in step by step. All right. So the first part we are going to look at what are variables. So variables in VBA are a container to store information. That information can be in the form of text, which in VBA we call it a string type variable. So it can be hello world, which is like a common in-joke in computer programming. I love VBA. It can be a single letter. It can be an empty space. It can be an exclamation mark. It can be a punctuation and so on. The other common type of variables in VBA are numbers. But VBA stores numbers in multiple ways. So in this case, there are 3 types of numbers. The first is an integer. So mathematically, you know what is an integer, right? It can be a positive or negative or 0. That's an integer. And for non-integer numbers, you store them either as a single or a double. So the difference between a single and double is what they call the floating point representation, which will determine the accuracy of the calculations. So in most cases, I'm going to assume that you're using the double variable type. But usually there is no reason to use single unless you're running a lot of calculations that is going to take a lot of memory, because the single variable type actually uses less memory as compared to the double variable type. So the other variable types in VBA include the Boolean variable type, which is either true or false, and it's usually used for certain logic operations, which I will not cover too much in this workshop. There is the variant variable type. The variant variable type is when we don't know in advance whether we want to use a number or a string, then we can define as a variant. And we have also other like array, and we also have long range, date, currency, and so on, but I will not go too much into that. And finally, the most common variable type that you will encounter is actually the variable type called empty. And it happens if you try to call a variable that you forgot to define. It will be defined as an empty variable because you haven't defined. All right. So this seems a lot to take in. But no worries. We are going to show you in VBA how to do it. And that's going to make it much easier to understand. All right. So I'm just going to stop sharing my screen now, and I'm going to move to our Excel worksheet. And then I'm just going to show you how to do that in your own Excel worksheet. All right. So let me just stop sharing. And we open in this Excel worksheet. Just open. Right. So first and foremost, How do you access the VBA IDE? You do that by going to the Developer tab on your ribbon. And then you click on Visual Basic. So this will then show the IDE on your screen. So the first question that most people will have at this time, because I've been giving these talks to about 1,000 people, and the most common question I get is, I don't have the Developer tab. What do I do? If you don't have the Developer tab on your screen, go to File, Options, Customize Ribbon, and then on the right side, make sure that this Developer button is ticked. If it's not, you can just tick it and then click on OK. And the Developer tab will appear. Then you can open it. So I'm just going to open the Visual Basic, and I'm just going to minimize the window a little so that you can see it better. Okay, so let's get into it. So your screen looks a little bit different from mine because I have accidentally closed the window. So if you're missing anything on your screen, click on View. So just click on View, and then whichever menu that you're missing. So in this case, this is actually the code window. So I'm just going to open it. So you now have the VBA screen that I'm showing you on your slides. All right. So let me just go back to the slides and let's compare it with the window that I just opened. Right, so this is the same window except that it's missing some text because I've just typed in as a done. So on the left-hand side here, we have what we call the project window. So the project window basically shows you what you have open currently. So I have, for example, I have a Excel worksheet called Book 1 open, and it has a sheet 1 inside it. So that's shown in the project window. And you have the properties window, which actually shows you the properties of the currently selected object. And then on the right side here, you have what we call the code window. So this is where you type in your functions and subroutines in this part. And finally, you have the immediate window. The immediate window is where you run your code. So that's why it's called immediate. That's why things happen immediately. All right. So we are just going to go ahead and do some variable manipulation, and you can see the different types of variables. Okay, so I'm back in my IDE. So for now, we are going to use the immediate window, which is on the bottom of the screen. You can click into it, you activate the window, and then you can start typing things. So how do I use variables? The first thing to do is to define the variable. So you can just, for example, type in x equals to 2, and then press enter. And that's going to define a new variable called x, assign the value of 2, and then save it in memory. So nothing is going to happen when you press enter because I'm not telling Excel to do anything. So I'm just defining the variable and saving it, so it does exactly that. In order to show the value of the variable, I need to use the command debug.print. And the thing about VBA is when you start typing a command, a hint will usually pop up telling you what to complete the command. So in this case, I'm actually trying to type in the word print. So you can see the print actually pops up in a small pop-up menu. I can click on this print and it will fill in for me. Or I can just type out the word print. And then after typing this command, I type in the variable name that I want. For example, it's x. So I just type x and then I press enter. And then it shows the value of 2, which I just assigned to x. You can, but the common way of doing that in the immediate window, which only applies to this immediate window, is to type in print. And then open bracket, variable name, close bracket. But it also shows you the value. This only applies to the immediate window, because if you try to do it in Excel, it will get confused between actually printing out the document. So that's why you can't use it in the actual Excel worksheet. So, but in the immediate window, the shortcut is just type print. So how do I know, for example, what is the type of X? We do that by printing out the type name of X. Type name. So type name actually tells you the type of a variable, but I have to tell it the name, the variable name, which is the var name here. So I will just close back this bracket, and I will close back the outer bracket. So same with any other programming language like Python or MATLAB, the brackets must be in pairs. If I open the bracket here, I must close this bracket. And when I open this bracket in front, I must close this bracket at the back. Then I press enter. And it shows the type name of X is integer. Because I assign the value of 2, Excel automatically defines it as an integer. So that's self-explanatory. So let me define Y as 1.5. And then I press enter. Then I try to print the type name of Y. It shows me the double variable type, which means a decimal number. So a decimal number can be single or double. There are actually others, but just ignore them now. So, but as default, Excel will assign it a double type, just to ensure the maximum accuracy is preserved when you do any calculations. And you can also define variables that are text. For example, I will define the variable Z as the word hello. So Z is just the word hello. But in order to define a text variable, we have to enclose the content in double quotation marks. Then only Excel will recognize it as text. Then when I press enter, thing happens. Then I can print out Z. It shows the word hello. And then I can print the type name of Z. Then it shows the variable type as string, which is a piece of text. That any piece of text, it can be a space bar, it can be a punctuation mark, it can be a mixture of capital and small letters, it doesn't matter. The final variable type is the Boolean variable type, which is either a true or false. So I will define the variable A as true. And when I print out the type name of A, it will show the Boolean variable type. So please don't get confused by the word true. So in this case, if I type in true with quotation marks, it's going to recognize it as the word. It is a word of text, the word true, T-R-U-E. So when I print out the type name of B, it's going to show as string, which will create some confusion in Excel if you try to use this in a logic operation. All right, so don't get confused. And it's also possible to accidentally define numbers in a string. For example, if I enclose this number in a quotation marks, it will also be defined as a string, which will then create some problems if we try to do any mathematical operations on the number. All right, so it has to be a variable type before we even start doing anything on it. Otherwise, it's going to have a lot of errors. All right, so this is a short introduction to variables. So let's go on to the operators so that we can finally start manipulating these variables that we just defined. Okay, so we have in the operators here. So operators are basically manipulations that we can do on the variables. So in the start, we have all the mathematical operations. We have plus, we have minus, multiply, which is used the asterisk symbol, and divide, and also the exponent variable, exponent operator. So these are the common mathematical expressions. We have the assignment variable, which assigns something to something else, which I just demonstrated actually. And we also have the comparison variables. So that we can compare something is greater than, less than, equal to, less than or equal to, greater than or equal to, and so on. And finally, we have the Boolean operators, and, or, and not, with a not being a special case, which is only used in certain logic operations. So I'm just going to demonstrate it to make it easier for you to understand. Okay, so we are back in the IDE. And what I'm going to do is I'm going to select everything in the immediate window and just delete, just to give me some more space to work on. And then I'm going to start defining some variables, and I'm going to start doing some things on them. All right. So let's define A as 2, B as 3. Then I define the variable C and assign it to the value of A plus B. So we expect C to be 5. That's elementary matrix. So let's plot C. You get 5. So this is a very simple operator, which is you can also do it directly inside the print command. For example, A minus B. You get -1. I can put in A multiplied by B. You get 6. I can put in A to the power of B. I get 8. So these are just standard mathematical expressions, nothing too fancy. You can also do comparisons in Excel. For example, I can print out A equal to B. In this case, it does not assign the value A to B or B to A. What happens is it tells you whether A is equal to B. So that is the difference. So when I press enter, it says false because A is not equal to B. So because A is 2 actually, so obviously A is not equal to B. So that is the assignment variable, assignment operator. But when you put it in another command, it turns into a comparison operator, which actually compares whether A is equal to B. So let's try it out with non-numbers. For example, let's say I define C as the word hello, and I define D as the word goodbye. So I'm not very imaginative with words, so just use simple words here. And I can actually just print out C plus D. What happens is that Excel will combine the two strings. If I try to add two variables that are strings, Excel will combine them, but without a space. So if I want that space, I have to add it myself. So for example, if I want a space between hello and goodbye, I have to type in here, and then I press enter. For goodbye, maybe I want an exclamation mark, and then I press enter. Then I can delete this, and I rerun this command, and I get the expression that I want. So text for string type variables, only plus will work. You cannot multiply, you cannot exponent, we cannot divide. All right. And finally, the last type of variable will be the Boolean variable. So for example, I can assign E to the value of true. So I can print out E, so that's true. So nothing special since I just defined as true. I can also assign variables to be comparisons. For example, F can be equal to A is greater than B. This actually tells it to compare A and B if A is greater than B. So this answer is actually false because A is smaller than B. So that will save the value of false into F. And you can also use brackets like mathematical operations to define which part to read first. For example, I can actually print out A plus B multiply B. So it's going to follow the multiplication first, then add A. So I can also use brackets to control. I want A plus B to be done first, then only multiply by B, then you get 15. So that's something you have to take note. Otherwise, you might not get the answer that you want. And this also works with comparisons. For example, I can print true. I can print, let's compare, is A greater than B and A less than B? So the answer is false because the AND operator is a Boolean operator that requires both of the statements before and after to be true. Only then the answer will be true. In all other cases, it's false. So A greater than B is false. A less than B is true. False and true reads as false. So that's the logic operation here. So we can also directly compare them. For example, I can just do the same thing, but directly type in the Boolean value I want, false and true. And then I get the same as false. If I change it to OR instead, I get true. So the OR operator means as long as one of the conditions is satisfied, the answer is true. So because this condition is true, the answer is true. Simple as that. And if I pass in 0 or 1, it will compare it as a true-false statement. So 0 will be represented as false, 1 will be represented as true. So it comes out the value 1, which actually means true. So this is something that can be done in Excel. All right, so we have done a lot of manipulations on these variables. But what exactly are we trying to do here? We are trying to carry out certain operations, right? So having the variables and having the means to manipulate them does not equate to having a function yet. So let's see how we actually start to a real function. All right, so let me just go back to the slides here. Okay, so we are back in the slides. And we are in Excel, right? There are two main kinds of functions. The first kind of function is called functions, self-explanatory. And the second kind of functions is what we call subroutines, usually simplified as the word sub. So what is the difference between a function and a subroutine? It looks similar, right? So a function is something that has an input and output. So it has an input and output. So for example, this function that I'm showing as an example here has the input called word. So this is a string that some random word that I just try to pass to the function. And then the function will take this word and save it inside this name, test function. So this test function is then the output. So basically this is just a dummy function that takes the word and saves it. It does nothing. But in real life, we would have very complicated functions that do a lot of things, right? So a subroutine has only input. So if I write this function as a subroutine, it will take in the input called word, and then it will print out this word. So it will print out in the immediate window because I use the command debug.print, and that's it. After that, it's going to forget the word. That's all, because it does not have an output. It does not save the output in the memory. So I cannot take anything out of this subroutine. A function can be private or public. By public, private allows you to prevent access to this function from other parts of your document, which usually doesn't make sense unless you have to do certain functions that require you to keep it in a certain part of the document. Otherwise, it's always by default public. And finally, it is recommended to declare all variables before you use them. So for example, in this function, I'm going to use the variable called word, which is a string. Excel is quite lenient in this regard, unlike certain languages like C++ or Python. You don't have to declare them before you use them. Excel will automatically assume, for example, that this is a string, and then it will act accordingly. But the danger of not declaring your variables is you might accidentally assign something else to that variable. For example, this word is supposed to be a string. But if I accidentally pass a number into the function, it will get accepted because Excel will think that this function is supposed to accept a number, and then you have a lot of problems down the road. So it's recommended to declare all variables before use by using the keyword dim. It is optional, but if you are sort of very particular or meticulous kind of person, you can force Excel to make sure that you define every variable before you use by calling the command option explicit before at the start of the document. But usually I don't become lazy. All right. So let's try defining a very simple function in our IDE, and let's try out both the function and the subroutine. Okay, so we are back here, and we are back in the same IDE. So again, I'm going to just select everything in the immediate window and delete them. Then I'm not going to ignore the immediate window for now, because when we write functions, we do them in the code window, which is above the immediate window. So I'm just going to make it bigger. And we write functions in this part of the IDE. Before we start writing functions, usually we would save this function not in one of these objects, but actually in a new place. And this place we will call a module. So what happens is I'm going to right click on the empty space in the project window, click on insert, then click on module, which is on the right left hand corner. And then when I scroll down, I make sure I double click this module. If I double click on it, and then I make sure that this property window is showing module 1, which means that it's currently being selected. And this is where I'm going to store my functions. The reason being that if I store it inside any of the sheets, right? For example, if I store it inside sheet 2, it will not be accessible outside of sheet 2. If I try to do it in another sheet, it will not be accessible. So it's best if I save it somewhere external in a module. And the module is good also because you can export and import things. For example, I can right click on it, click on export file, and save it on my computer, and then I can share it to someone else. Same thing, I can import file and open it written. So it makes it very easy to share your code with your friends, your colleagues, your classmates, and so on. All right, so I'm just going to go back to this module here. And in the properties window, there is a field called name. And here is just where I put the module. So I can put in whatever name that I want. And then it renames it automatically. Right. So let's go into actually defining a subroutine. So let's try a subroutine first. So click inside the code window. And then I define the subroutine by typing the name SQB sub, followed by the name of the subroutine that I want. So let me just call this subroutine a test sub. And then open close bracket. Usually I would name them as a capital letter in the middle, just very easier to read, but it's not mandatory. You can name it any way you want. And then I just press enter. Excel will then add in this line, end sub, which means that Excel has detected that you are trying to run a subroutine. So that's a good thing. So whatever that's inside the subroutine must be defined inside these two lines. Must be defined in these two lines. Okay, so I can just enter it out and give it more space. And this subroutine will do nothing except just to print out the line called hello. So this subroutine will do nothing except to print out in the immediate window the word hello. So after I've done that, the best thing to do is to save the document to make sure that it doesn't disappear or it doesn't crash or anything. So when I do that, an error will pop up saying that the following features cannot be saved in macro-free workbooks. So the issue is that if you are using VBA, you have to save it as a the Excel macro-enabled workbook file format. The Excel file format. The normal workbook will not accept the macros. If you try to do that, all your VBA will disappear. So I'm just going to save it as the XLSM file format. Then I press save. Okay, then my subroutine is ready. So how do I run it? There's a play button on the toolbar called run sub or user form. So I press that, and it shows a list of macros. So basically, macro is another name for a subroutine in Excel. If you heard of the name macro, it's actually a subroutine. So I can just click it and press on run. And then it prints out the word hello. well, that's what we expected it to do. Right? So that's how it goes. So I said that a subroutine has an input, right? Has an input. Here we have no input. What happens when I give it the input? Let's say, by giving an input, what I do is between these two brackets, I type in the name of the variable that I want to store the input in. So I will use, for example, the word variable. And then when I print out, I want to print out this word. And then I save it. And I clear this. And when I do this, I cannot run it anymore. It appears in the macro. The reason being that I need an input. I need an additional parameter before I can run this subroutine. So what I can do is I can run in the immediate row, typing the subroutine name, test sub, and then give it an input. For example, the input is the word hello. Again, in double quotation marks to make sure that it's recognized as a string. I press enter, and then this input, the string hello, gets saved into the temporary variable word, and then it gets printed out by this command, debug.print word. Let's say I try something. For example, let me just add this, use an operator, add operator in this sentence, delete this, save the document, then run it. Then it prints out the word hello twice, because that's what I asked the command to do. So this is a subroutine. But when let's try something else. For example, I call test sub with a number, let's say 2. So you print out 4 because the parameter 2 we pass in the word. If we send here, it will replace by 2 plus 2. So it prints out the number 4. So that's a subroutine. Then what happens if I try to use this subroutine in another equation? For example, I try to type in print 2 plus test sub 2. So logically, we will expect this will come out as 4. This equation will then become 6. But when I try to do that, I get an error, expected function or variable. The reason being that after it prints out the number 4, it just forgets the input. Because the subroutine cannot have an output, it doesn't remember what is the number that it has just outputted. So to do that, we need to use what we call a function, right? Well, we need to use a function. So I'm going to change this to a function by just selecting the sub, and then we name it as a function. And then when I click somewhere, Excel will actually change this line to an end function, which means that again, it has been extended as a function. And then I will need to give it the output by assigning what is the output to the function name. So the function name here is test sub. Let me just call it test function so that no one gets confused. And then we need to assign the test function as whatever that we are trying to do it. For example, in this case, I'm trying to add up, just double the input. Okay, so let's save it and let's try to run it. Let's do it with the word hello again. So you get hello, hello. All right. And then I can now use this function inside other statements. For example, I want to print out the word hello plus this function. I'm just going to copy and paste here. And it's going to print out 3 hellos. So this line refers to here, the debug.print statement. And then this line is actually coming from the outer statement. So what if I don't want this line anymore? Is it possible for me to just disable this line? I can do that by typing a single apostrophe. Just type apostrophe on the keyboard. And this line will now become green. So the apostrophe actually represents what we call a comment. So this is a comment. And these are lines that will not be read by myself, but it's actually designed for me to just remind myself what I'm trying to do. So I can leave comments everywhere. However, I can also use this as a method to temporarily disable certain lines. For example, if I put this symbol here, this line will be treated as a comment and Excel will just ignore the line. So when I try to do this again, Excel skips this line. So this is the magic of the commenting apostrophe. Okay, so we now have the basics of functions and subroutines. So we can finally do something real. So let's go back to the slides then. All right, so now that we know how to set up these functions, we need to set up what is inside the function itself. So we can do that by conditional branching, which is an if-else statement, which is the most common example. Or we can do it via a loop, which is the other most common example. There are two kinds of loops here, which is the for next and the do while loop. The for next is the easier of the two. So I'm going to use that as the example here. So let's try doing it in the VBA. Okay, so we are back in the VBA screen. So just to make sure that I don't lose anything in the IDE, I'm going to create a new module. Right click on the project window, insert module. And this module, I'm going to change the name to, let's just say example1. Just to call it an example. And I'm going to define this as a function. And I'm just going to call it example1, maybe in small letters. And the function will need an input, but we can leave it empty for now. So in this function, I'm going to give it an if-else statement that will print out either hello or goodbye or see you later, something like that. So we can define an if-else statement by typing the word if, then we type in the condition. Okay, so it's missing the condition. So I'm going to give an input. The input, I'm just going to call it maybe something like I. Just use a number I. And if I is greater than 0, then I'm just going to say hello to the user. So you just type in the word then at the end. And then I'm just going to debug log print. Hello. So this function itself is enough. It is a complete if-else statement, and I can then run it. So I can call this function by typing the function name, open close bracket, and then inside the brackets, the input required by the function. So in this case, it wants a number I. So let me just give it a number 5. Oh, my apologies. I have just conflicted the name conflict with the module. I have to give it another name. So let me just call it, I don't know, maybe test function 1 or some funny name. So let me just call it test function with the number 5. Something's not happening. Oh, okay, I forgot to do something. I forgot to end this statement. Give me a second here. So the if-else statement is supposed to have an end. Let's try doing that again. And if, my apologies, should be if. Debug this, then try. So it says hello. Okay. So, but an if statement alone is actually not very powerful because there's like many situations that I want to use it in, right? So the next thing I can put inside if-else statement is the word else. So else will work if the condition is not satisfied. So for example, I can put in else just print goodbye. All right, then I'm going to save it. Let's call it with 5. Let's call it with 0. You get goodbye. Let's call it with nothing. Let's put something -5. You also get goodbye. So an else statement is optional, but you can put into your if statement, make it stronger. And finally, you can also put in what we call an else if. So for example, if I less than 0, then I will print hello and goodbye. Okay, so I'm going to just do this. So let's print the last one, and then I try it again. So you get hello and goodbye. So the if statement is mandatory, the else is optional. You can only have one else, and the else if statements, you can have as many as you want, basically. So I can actually have another else if statement that says if I is exactly equal to 0, then just print out hello and goodbye without the end. And then I'm just going to delete this and then enter, and then you get hello and goodbye. So it follows this statement. So you can have infinite number of else ifs. But if you have too many else if, there's another way of doing it. The function we call case, C-A-S-E, but it's not. I'm not going to do that today. So if else is the easiest way to understand basic conditional branching. So this is everything that we can do for branching. So if a certain condition happens, we do this, another condition, we do that, and so on. We can also do what we call a loop, which is we repeat a certain number of action multiple times. So let me just create a new module. And I'm going to call this example 2, because I'm not imaginative in names. And I'm just going to call this a function, test function 2. And then it uses the same variable I as input. And in this test function, we are going to try out the looping. So let's make a simple loop. This loop will just print out any number starting from 1 to I. So we can do a simple loop by using the keyword for and next. So for and next. Let's say for n equals to 1 to I, we just print out n. That's it. That's a function. And I just delete everything in the immediate window. And I just try out test function 2 with a number maybe 10. So it prints out the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's it. And let's make it one common thing that we like to do in loops is to do it iteratively. For example, every new item adds something to the previous number. For example, I want it to print out the Fibonacci sequence. So what do is I define a temporary variable to store the current n. So I define variables by using the keyword dim, as I previously introduced. And then when you type in the keyword dim, you have to give the variable a name. For example, let's call it sum. And then you have to use the word s to define the variable type. And I'm just going to call it an integer. So you can see that Excel gives you a selection of all types that you can do in Excel, which is like 2,000 types of variables. I'm just going to define it as an integer. And then inside this for loop, I'm going to add sum to the current number, which I do by typing sum equals to sum plus 10. This is very common statement when it comes to programming, which means take the number that I have, add this new number into it, and then store it inside the original variable. You have to store it, otherwise it will just forget it, and then nothing happens. And the last thing I need to do to give the variable sum an initial number. Otherwise, it doesn't know how to add a number to an undefined variable. So you will put in the value 0 here, and then it saves it in n. So I'll try to delete everything. Then just going to press enter. And then it just debugs for print n, okay. And let me just disable this column, this statement. And then I put in a new statement to print out the count. So you get 1, 1 plus 2, 3 plus 3, 6 plus 4, 10 plus 5, 15 plus 6, 21 plus 7, and so on. So that's what happens. And before we end the function, just remember to assign the function name to the variable that I want to save the output in. So in this case, I want the output to be sum. So I will save it in as function. So I will disable this line. And in the real application, I will actually do this. Print test function 10. And I will only get one answer, which is the last answer that I want, which is 55. So this is how you define a loop inside a function. And that is one of the common use cases. Calculating the Fibonacci sequence can be something that you can try out in your free time. Then you can understand the concept of a loop. Okay, so up to now, if you have any questions, please let me know in the chat before we continue on to the more tougher parts of VBA programming. All right, so if you have any questions, please do put them down in the chat, or you can ask them even on screen. I'm okay with that. Otherwise, I'm going to just proceed with something interesting. And for our first real function, let's not make it too difficult. Let's just do a simple one. So if you are the kind of person that likes to read kind of motivational posters on social media, you see this kind of posters frequently. What makes your life 100%? And then apparently skills only make 82% of your life, knowledge 96, hard work 98, and then attitude 100. So what they do is they add up the letters with A representing 1, B equals 2, and so on until Z equals 26. And then apparently attitude is everything. So basically that's what they're trying to say. Attitude is the main kind of thing that actually affects your life. So that's what they're trying to say here. So just to make an interesting game, can we actually write a function that tells us this number? So if I input the word skills into this function, it will tell me 82. Knowledge 96. Hard work 98. All right, let's try this out. But before we start coding anything, it's best to actually sit down, get a piece of paper, get a pencil or a pen, and start drafting out what we want to do, step by step, like you're trying to teach this to a 3-year-old child. First, I'm going to take the word attitude as an example. I will separate out each letter. I will convert the letter to the respective number. I will add up the numbers, and then I want to only retain the last number. I only want to know the last number. The numbers in front can be forgotten. I don't want to care about those numbers. I just want the last number. So after I draft this out, it makes it much easier for me to actually do the coding in the Excel code. So this is something quite important actually when it comes to doing any programming. So let's do it in the IDE. Okay, so we are back in the IDE. So I'm going to create a new module. I click insert module. I'm going to call it example 3. And I'm going to define it as a function because it has an output, which is the number that I want. And I'm just going to call it the word score. And this word score will need one word, which is, I'm just calling it the variable name word. Let's enter. So end function come up, it shows that I have defined the function correctly. So let's do the first step, which is to read the word. So to read the word, just to make sure that I read the word properly, I'm just going to have Excel print out the word itself. All right. So I'm just going to call the function word score, word, let's say attitude. Then it prints out the same word. Okay, that's good because I have successfully inputted the word into the function, which is already a very big thing. Because if I cannot get this step right, whatever I do later on will be wasted. Okay, so now I'm going to separate the word attitude into the component letters. So if I sit down and think about it, I will probably need some kind of loop, right? Because I need to take out the letters one by one for 1, 2, 3, 4, 5, 6, 7, 8. I need to do something 8 times. So most probably I need a for next loop. So let me just disable this line. And I'm just going to write in a for next loop. And probably I need some kind of variable as a temporary number. So I just use I equal to 1 to 8. So this is the length of the word attitude that I want. And then I'm just going to end this loop by typing next. So I have defined a for next loop. And inside, I want to extract each letter out of it. So let me just debug log3. And I extract each letter by using the function called mid or MID. MID. And then I give it the word that I want. So when I start this function MID, you see a tooltip pops up telling me that I can type in the string that I want. The second input required is the start position. So this start position will be I. And the last input is the length. So I want only one letter. So I type in 1. So in this tooltip, you can see the length parameter here is in square brackets. This means that it's optional. This means that optional. So I'm just going to close back this one, close the bracket, and then I'm going to run this again. So I get every letter out in the immediate zone. So that's step 2 done. Right? That means step 2 is to recognize each letter. So that step 2 is now done. So step 3 is now to convert each letter into a respective number. So I will need to store this output inside a variable. Let me just call it a current letter, because it's a current letter that I'm trying to read, right? And because I have this variable here, it's good to define the variable. So I'm just going to type in dim current letter as string, because the letters are stored as strings. So I have to use the string variable type. And that will be all. So I have done step 2. So step 3 is to convert the letter into the respective number. So I do that by using the function ASC, debug between ASC current letter. So let's see what happens. So we got a series of numbers, but there is something wrong here. A is written as 65, B maybe 66, C 67, D 68, E 69, and so on. So there is something wrong here. So there are some ways of doing that, but the easiest way is if you recognize that this number is actually 64 more than what I want, I can just type in minus 64 from the end. And then when I try to run that, I get the numbers that I want. A is 1, E is 5, D is 4, and so on. So this is what we want. So I'm just going to store this in maybe current score, in a variable current score. And then current score will be an integer. So I'm going to define current score as integer. If I do not define it, it might be defined as a double. So I just keep it as integer. Finally, I want to add up every number. So I want to get 1 plus 20, 21, 21 plus 20, 41, 50, 17, 99, and so on. So this should require a temporary variable. So let me just define it as a temporary variable. So this will require a temporary variable as I shown in the previous example. So I'll just call it score equals to score plus current score. So that's all of it. And maybe I'll just define score as an integer as well. And if it's the same type, I can just type a comma here and then type in score. And that will define both these variables as integer. which to me is good enough. And just finally, I just want to know what is the current score by typing debug tree score. So debug statements help a lot in terms of like letting me know what Excel is trying to do. And just to make sure that what Excel is doing is what I want. So this is a whole function. So let me just delete this and enter. So I got 21, 41, 50, 70, 91, 95, 100. That's good. That's what I want. The final step is to store the output in the function. Otherwise, it will forget it, right? So what I do is before the end function line, assign the score to the variable, to the function name. So this is what I want. And then I'm just going to disable this line. Then nothing happens because I will now need to print it. Okay, so I get 100. So it seems that my function is now complete and it gives me what I'm trying to do. So all the 5 steps just shown on the slides have been completed. So congratulations. Next, we are going to look at how we actually use it in our Excel. Because now, until now, I've just defined this function in the IDE. I've just been playing around with it. But there's no real application. There's no real application as of now. But how do we use it in Excel? That's the most important part. Right. So I'm just going to leave this for another few seconds. If anyone needs it, you can copy it down or something. So otherwise, I'm just going to move back into my Excel sheet here. Okay, so we are back in Excel, and I have saved the code in the IDE. I have saved my function. So now let's see how we can use it in the real Excel sheet. In Excel, we know there are many built-in functions. For example, we have sum that you can add things up. We have average that can calculate the average. But what is special about what we have done now is we have defined a new function called word score, which we can actually find by typing in word. And then you realize that Excel is actually, there's a new function here that is not present previously, right? It's actually called word score. And then I can press on open bracket. Word score has one input, which is the word that I'm trying to click. So I can click on actually this cell, close bracket. Then I get 100. So this is the beauty of VBA, defining custom functions, right? Custom functions inside VBA. So this is the beauty. And then I can manipulate like any other function by dragging it. Then I get the function copied down, and then the cell that we have referred to this accordingly. So you can see that there are actually something wrong with the word knowledge, and there is something wrong with the word which parents. So which parents may be a very important factor in life, right? So, but treating as 41. So there's something wrong here. I will not cover why this is wrong. I'll just let you do it as an exercise. So if you scroll down a little, there are some exercises that you can do on your own free time. But I'm just going to recognize why is knowledge not giving the correct score. So if you remember, the score for knowledge should be 96, but it's actually showing as 91. So why is that happening? The simple reason is, if you notice, the difference between 91 and 96 is 5. And 5 is the value for E, the last letter. The reason being that in our code, we fixed the length to 8. And knowledge has 9 letters. So that's why it's ignoring the last letter. So we can change the code by typing len, L-E-N, which stands for the length. and the length of the input word. And that will mean that any length will be accepted. So I can just save this. And when you change anything in the IDE, the values do not change immediately. Go inside it, press enter. You get 96, which is the correct answer. All right. So it seems that we have managed to do it like we managed to get our first custom user defined function, or UDF, completed. So congratulations, everyone. So we can now start doing the real chemical engineering part, which I will go a bit faster because I'm sure that you guys have know the basics by now. Hilary or Wei, you can let me know if there are any questions before I move on, just in case anyone has any trouble getting function done properly or anything. Are there any questions in the slide? Or we can leave it into the end if there are no like specific questions regarding the coding. Okay, so it seems that we have no questions for now. So I'm going to assume that everyone has understands and has managed to get this done. So if you want, you can take a screenshot, or you can just have a look and then try to type it out. I will try doing it in Zoom, but I found that you cannot copy out of the Zoom chat, so I can't give it through that way, unfortunately. So yeah, so this is the code. Let me know if you have any questions, or if you have no questions, just give me a done in the chat box so I can know that it's time to proceed. So give me a done in the chat box if you are okay to proceed. Okay, looks good. Seems like everyone is still interested for more. All right, so now let's go ahead and let's go into the real chemical engineering application of VBA. So this is just a warm-up game, all right? So let's try using VBA in the most basic of chemical engineering applications, what we call mass and heat balances. Mass balance is not fun for VBA because mass balance is something you can do on a paper or pencil or calculator, all right? So let's try doing a energy balance calculation in VBA. And for this example, I'm just going to show you how we do heat capacity calculations. So in case you guys have been skipping classes for about energy balance, heat capacity is defined as the heat energy required to raise the temperature of 1 mole of substance by 1 degree Celsius. And in this case, defined as joule per mole per Celsius or joule per mole per Kelvin. If you look at your textbooks, and actually in real life, heat capacity is given in an equation, usually with some constants A, B, C, and so on. And these constants are published in things like Paris Handbook or the NIST website, and so on. So Steve here is an engineer. He wants to calculate the heat capacity of oxygen, nitrogen, and carbon dioxide at certain temperatures. So heat capacity is temperature dependent. So the real equation has more terms. There are actually power 3, power 4, power 5 terms. But just for this example, I'm just going to use the 3-term version. So don't try to use this in your homework calculations. It's not accurate. You have to add in the extra terms. And the terms are actually a multiplication between a constant. And this constant depends on the type of gas. For example, O2 has its own constants, N2 has its own, carbon dioxide has its own constants, and water has its own constants, and so on. And then each constant is multiplied by a number. So A is multiplied by 1, B is multiplied by temperature, which must be in Kelvin. Which I think you know how to convert Celsius to Kelvin, right? Just add 273. And then the next term will be T squared, T power 3, T power 4, and so on. So let's develop a function called Cp, which stands for heat capacity, obviously, with 2 inputs. The input will be substance, because the constants depend on substance. So I need to know what substance I'm trying to define this for. And the second is the temperature in degrees Celsius, which I would then have to convert to Kelvin before I put into this equation. All right. So I'm just going to make it easy. I'm going to define substance as string in degree C as double. So let's do that in our IDE. So let me just change the resolution a little so it becomes bigger. You can see. All right, so we have the IDE. Again, creating a new module. We'll call this example for. Develop a function CP. So the function name is CP, C capital P small, open brackets. There are two inputs. The first input is called substance, which is the name of the gas I'm trying to use. The second input is the temperature, 3 degrees C. Then in this case, I can actually limit what are the inputs that are acceptable by the function. I can do so by typing the keyword S string. So this will ensure that whatever that's inputted in the substance parameter is only a string. Same thing with temperature. I want temperature to be only a double and nothing else. So I can just type in S double. So this is a shortcut way of defining variables. All right. And I can also define the CP itself as a double by typing S double at the end. So that's how I just, a shortcut method of just defining everything in one line. Okay, so we can see that we need to calculate the value of CP. So we need to save the value of the calculated value. And we need to choose certain sets of A, B, and C's. We need to choose that. So that means that we need an if-else statement. We need an if-else statement to decide what to use when. So we can define A, B, C as double, which are the parameters that I'm going to use. And then I will need an if-else statement. So I will use the if-else statement if substance equals to my first substance, which is O2, then, and then an if. So it's quite common to actually like do indents of inner loops just to make sure that I know which part which part actually which code falls inside which loop. So for example, O2 will be inside the function CP. So I just indent. And I will need one else if substance equals to N2, then, and then I'll need another else. Substance equals to CO2, then, and then maybe I'll put an else, and then maybe this will be, I will just tell the user this is invalid, just in case the user types in some funny things that I didn't expect. And for each of these if-else statement, I'm going to type in the constants required. So I will type in the values for A, B, and C. So just to make it quick, I'm just going to copy them from the sheet example form. So give me a second while I just transfer all the numbers into here. I'm just copying the numbers that I just provided to you in the sheet example 4. So for each of these substances, we have A, B, and C. Okay, and then we have C. If you are looking at the sheet, right, there is two other additional parameters called Tmin and Tmax. So those are actually like the valid region that you can use this equation for. So in a real situation, in a real mass and energy balance that I do for my company, I will actually pop up a warning message if the user tries to input a temperature that is outside that range. But in this case, I'm just going to make it easy and I'm just not going to include that check. I'm just going to calculate the values of requested substance at a certain temperature. So this is actually a real life code that I'm actually just applying as an example for you. So I have actually defined all the function, all the variables here, copy pasted. And then remember the last thing to do is actually to calculate the actual CP, which is A plus B multiply T plus C multiply T squared. Just to be safe, I'm going to put in brackets to make sure that Excel doesn't read that incorrectly. And that's it. And finally, one last thing is to do the conversion of temperature from T degrees C into Kelvin. Just don't forget this statement. So this is now a complete function. This is now a complete function that I can now use inside my Excel sheet. So let me just go back to my Excel and demonstrate to you how to use this. Okay, so let me just bring up this to one side so that in case you want to refer to it, you can have a look. So I'm just going to scroll down here and using the function above, calculate the CP of each gas. So here is where I use that function. Click on this cell, press an equal sign, CP, which will now be detected by Excel as a custom function. Bracket, O2, first input, substance as a string, temperature as double. Enter. So voila, you get the answer. Try to the next one, you get the answer. Try for the third one, you get what you call value error. So value error occurs when one of the inputs doesn't match the expected input. So let's see. Here we have the function which is linked to this cell, substance as string, T degrees C as double. So this is not a double. This is actually a string. When you have an alphabet in a mixture of alphabets and numbers, you get a string. So the problem here is doesn't detect this as a double and it doesn't work. What I can do is I can change this into a double. So I can just type in 300 minus 273 just to make a double. Then it will work. So basically 300 Kelvin is the same as 27 degrees Celsius. So that's how I get it. And the good thing about user-defined functions is you can use it in other calculations as well. For example, calculate the CP of a mixture of two gases, 21% oxygen by volume, 79% nitrogen by volume, both at 25 degrees Celsius. So I can do it by assuming a certain proportion, 21%, multiplied by the CP of oxygen at 25 degrees plus 1 minus 21% of the CP of nitrogen also at 25 degrees. And it fits seamlessly into your calculations. So this is how you use, this is the power of user-defined function. It works with any calculations that you have in Excel. So I can just mix and match with other multiplications and so on. I can even mix and match different user-defined functions. I can even use one defined function, user-defined function as the input of another user-defined function. That's the smart thing. Okay, so this is the first example that we have finished, which is actually related to the chemical engineering profession. And I hope you like it. If you have any questions, please let me know in the chat. I'm just going to leave this on the screen. So in case you need to have a look, we'll have a look here. And if you have time, please try out the extra credit questions. So I will just try out one question here. The first question, write a function CP underscore average AVG that calculates the average of CP at two temperatures. So I'm purposely giving this question to show you that functions can be used inside other functions. Let's go to our IDE, and you know what I mean. So this is the function that I just defined. And now I want to define a new function that is called CP underscore average. I can do that by moving one line after n function and just typing a new function, CP_average. I assume that I will need substance and let's say 2 temperatures. And when I press enter, Excel will actually add in this line to show that it has detected a new function. And you actually put in a line to separate the previous function. So that's good for Excel. And then I just want to calculate the CP, the average of the CP at 2 temperatures. So I need to calculate 2 different CPs. So let's call them CP1 and CP2. CP1 is actually the CP of the substance at T1. So you can see the tooltip popping up, substance as string, T degrees C as double, S double. So this actually refers to the function that I just defined above. So again, I'll do the same thing for CP1 and CP2. And then finally, I will assign the function, the output to a function name, which is basically CP1 plus CP2 divided by 2. So this is the average of the 2 values. And then I can call it now inside the Excel worksheet. Let me just select a random cell on the right side here and or maybe just CP_average. That's for oxygen perhaps. Maybe at 25 degrees and 100 degrees. Oops. Oh, there's a typo here. Second. Oh, okay. There is a by reference argument type mismatch, which means that I need to define this as a string so that it fits exactly with the same type as above. P1 will be S double, P2 will be S double, and CP average will be a double as well. Let's try it again. So I get a number of 32.5212. So how do I know this number is correct? Let's try it manually. The first will be the CP of O2 at 25 degrees. The second will be the CP of O2 at 100 degrees. And then I use Excel average function to calculate the average of both numbers. So you get the same answer. So this is a way that we can actually simplify certain calculations in a user-defined function. So we don't have to keep manually calculating them and then averaging them ourselves. All right, so I'm just going to delete this. And let me know if you have any questions or any trouble like getting any of the functions to work before we move too far ahead. Otherwise, I'm just going to go ahead with the next example. Okay, so the next thing I'm going to do here is by doing a numerical methods, which is an equation solving method. So Steve here is trying to finish his math homework. He's trying to solve an equation, but he couldn't. So many equations in thermodynamics and other applications actually require you to find the root of a function, which is the value of x when fx equals to 0. One method that you can use is called the bisection method. There are many other methods, but this is the easiest to do in VBA. So the bisection method is a root finding method that requires 2 initial guesses. And with the 2 initial guesses, the bisection method will calculate the midpoint. So the real answer is here. And then the bisection method will decide to continue on with either the left or the right interval. So in this case, the bisection method will continue with this interval, then calculate the midpoint, and then divide into a second interval, calculate the midpoint, divide into a second interval, calculate the midpoint, and so on. So this is the bisection method in a nutshell. And to do that, we actually need to know where the function crosses the x-axis, or in another way, we want to know when the functions have different signs, one's positive, one negative. So to save you some time, I've written out how exactly I want to code the bisection method. Let's call it bisect. We have A, lower guess, B, upper guess. Max iter is the number of iterations I want to run this function for. And that way is first to calculate the midpoint, which I will call C. Then substitute the function values and then check where the root lies. If the root lies between A and C, choose A and C as a new interval, go back to step 1. And also same with if the interval is between C and B. Repeat until we reach max iteration, then output the answer to the user. So let's try it with the function minus x squared plus x plus 50. So I actually found out the answer via Symbolab online calculator. So you now know the actual answer, which is negative 0.98076 and 50.98076. So you won't have answer in real life, but in this example, it's good that we can compare our code with the real answer. So this is how I would do if I do it with a pen and paper. Now, narrow down each interval, narrow down, and after 18 iterations, I would get the answer that I want, which is 50.98076, which is this value that I wanted. So let's see how we do it in Excel. Okay, so again, new module, insert module, example 5. Oops, here. Let's define a function called bisect with the input A, B, and max iter. So in the interest of time, I'm not going to type out all the definitions that are, for example, as double, as integer, whatever. But this is just to save time. And I need to first calculate the midpoint of A and B, which let me just call it C. C equals to A plus B divided by 2. And then because we have an iteration here, we probably need some kind of loop to loop through until we reach maximum number of iterations. So I'm just going to use a for next loop again. For I equals to 0, maybe 1 to max iter. Calculate the midpoint. Substitute the function values. So the function here is, minus x squared plus 50x plus 50. So I'm just going to calculate the three values, the FA, the FC, and the FP. In just of time, I'm just going to copy this line and then change it to the correct variable. Just space it a little bit here, and then just make sure that there'll be a bracket here. Otherwise, if you calculate as negative A squared, you should be in a positive number. Then I will do this with FC, which will just change this to C. And then finally FP, which will just change this to B. And that's it. That's the first step and the second step completed. The third step is then to detect whether the two sides FA and FB have the same sign or not. So what I do is I need an if-else statement. So let's say if FA multiplied by FB is greater than 0. Sorry, it's less than 0. Then, and then I need else if FA multiplied FB greater than 0, then, and then I need an else if FA multiplied by FB equal to 0, just in case I accidentally reach the correct answer, because some equations have an exact solution, right? So the solution might be 3, exactly 3. So if I don't put in the equal sign, it will not be detected as an exact solution. So if I have reached the exact solution, I want the function to exit immediately. I want to continue until it reaches the max iterations. For example, I might have set max iterations to be 1000. But if it has already reached it by iteration 18, I just want it to stop there. So it doesn't go on wild goose chases. So I can set this. I can do that by again assigning the variable name to the answer, which in this case will actually be bisect. This will be C. I guess capital letter doesn't matter. And then maybe I have one else statement in case the user types in something else. I'm just going to print out a invalid input. Tell the user that you are typing something that's not making sense. For example, you might have typed in the script in the A and B. So let's do what is it here. So if the function has a different sign, it means that, sorry, give me a second. Okay, so if the function has a different sign, FA multiplied B will be less than 0, and this will mean that the solution lies in the first interval. That means I want the iteration to continue in the interval A to C. So what I do is I assign the new B to the old C. Remember that in Excel, right? When I type in this way, it assigns the value of C to B, which means I'm actually changing B. I'm actually changing B. C maintained. So if the second condition, FA and FB are the same sign. Sorry, actually this should be FC. If FA and FC are the same sign, the root lies in the second interval, B to C. So I want the new A to be B. I want the new A to be C. Sorry, I want the interval to be C to B. So the new A should be C. And the last, yes. So this is how the iteration works. Let's try it out and see if it works. So put that immediate window here. Okay, so let's do that by just printing the value. For that, let's finish it by assigning the variable name to the current value of the new point. Let's try out bisect 0 to 100 and then 1 iteration. Got a closing bracket here. Oh, I forgot to put in the next. My apologies. Should have a next here before assigning the variable. And then it's in debug mode, so I have to click on stop here, reset. Then I just type again. So I get 50. Okay, looks good. Let's try to move it more iterations, maybe 10. Okay, looks like it's working. Maybe let's give it 100 iterations. Okay, so I get, what's this? Oh, because it's out of range. Okay, no worries. So I'm just going to go back to my Excel here. So this one should be FC. And then we can use it in the Excel sheet. Okay, let's go to example 5 now. And bisection method. I've actually done the whole bisection method manually in here to get the answer. So you can see that manually doing it is actually very time intensive. There's a very big table here. But once we have defined our custom function, I just have to call it by 0, 100, 100. Then I get the answer immediately. So that's the magic of VBA. So this is the correct answer, and the same answer that I would have gotten if I had done it via the manual method. All right, so this is one numerical method done. So again, if any questions regarding the specific code, I will just bring up again the code here. And then if you have any questions, please let me know in the question and answer session about whether you have very specific problems or you have some errors popping up that you have no idea what it is. Don't panic, just let me know. All right. So we are going to go to our last 10 minutes will be the final and last example for today, which will also be another numerical method, which will again be a numerical method. So let me just go back to my slides here. Okay, so our last example will be example 6. And this is also something that is, to me, I struggled when I was a student in what we call the reaction engineering class. So Steve here wants to design a plug flow reactor. So if you know, there are 4 common types of reactors. There's a CSDR, there's a batch reactor, there's the plug flow reactor, there's the static reactor. So there are 4 types of reactors. The most difficult reactor to design is the plug flow reactor and the backbreak reactor, because you need an integration step to size the reactor volume. So the reactor volume is defined for PFR to be the inlet molar flow rate multiplied by the integral of the conversion between 1 and 2, the inverse of the rate reaction, the inverse of the rate equation, and then integrate by with respect to x. So this is something that is quite difficult to do. Usually if you are in class, your lecturer will get you to take out a graph paper and then plot the values on the graph paper, and then you calculate the squares, and then you get the estimate of the reactor volume. So that's what the way I was taught in class. And this is what we call a Levin-Sphere plot, which means that we assume that the area under the curve can be estimated by using rectangles, or some people use trapeziums or squares or whatever. But we can actually estimate the area under the curve, and then we can manually calculate the area by just adding up with a calculator or what. So can we do this in VBA? So develop a function we call reactor volume, x values, y values, where x value will be this part, and y values will be this part. So it will make your reaction engineering homework much easier than how I did it during my university days. Right? So let's go into our IDE. Okay, so just to ease you, I've already plotted x from the required conversion here, and the reciprocal of the rate equation. So I just need to integrate these rates. So we are going to write a function that does that. Okay, so let's create a new module again. And for example 6. Sorry, I can't put a space in the module. It has to be just like that. And I'm just going to call it a function, reactor volume, x values, y values. All right, so simple as that. It's actually simple, but let's go ahead and see how we do it. The first thing is to get the respective x value and y value. So that's the first thing to do. So how we do that? We need a integer or some kind of iteration variable. So I'm just going to define I as a as 15. And then I will need a for next row because I want to go through every row in the data, right? I want to go through every row in the data, so I will need a for next loop. So maybe for I from 1 to 1, 2, 3, 4, 5, 6, 7, 8, 8 rows. And I need to calculate the area under each of them. So if I go back to the slides here, you can see that what I'm trying to do is calculate the area of the first rectangle. Let's start the first one. The area is actually 100 and then multiply by the width, which is 0.1. And then if you realize that this width is actually the same. So every rectangle is 0.1. Every rectangle is 0.1. But the height is different. So this 100 is slightly more than 100. This is, I don't know, maybe 120, 150, and so on. So we actually just need to multiply 0.1 by the current y value. So let's do that. So this kind of loops can be a bit difficult to understand in the first try. And it might actually take a bit of trial and error to actually think of how to exactly write them. So it's always good to actually sketch out on a piece of paper. Just like for this example, we already know what we're going to do, so I can go a bit faster. Let's do that. And I need a temporary variable to calculate the current area, which will be 0.1 multiplied by the y values. And then I will just define current area as a double. And I also need a temporary variable called area to save the sum as I keep adding on to it. So I'll just define both of them as double. And then I will initialize area to be 0. Then calculate area equals to the previous area, adding the current area. Okay, then finally I just assign the value to reactor volume equal to the molar flow rate is 2 multiplied by area. Okay, looks like it will work, right? So let's see if it works. I'm quite sure it won't, but let's see if it works. Okay, we now go back to our Excel. Then we have which is being blocked by the screen. All right, so calculate vector volume here. Okay, this cell equals vector volume, open bracket, x values, y values, value error. Okay, so what happened? The reason is that when I select a range of cells, it does not get read as a number. It gets read as an object that we call range. It gets read as a range object. And when it's a range object, I cannot just multiply the range object. So the y values in this case will be a range object. I cannot just multiply the range object by 0.1. I need to tell the range object to give me the value of the current row before I can. So how do I do it? Is actually in this range object values, I give it a dot, which calls the what we call a method of the range object. The method is something that we want from the object. So this is called method, and the method that we want is the value. So it's actually called value. But we don't want all the values. We only want the current value. So we do that by putting open and close bracket after. And then here we put in the coordinates, the row and column of the value that we want. So in this case, the input is one value, one row and one column. So the row that we want is actually I. The column is 1 because there's only one column in y values. So this is how we take out the value from a range object. So because a lot of these functions will be taking values from the spreadsheet, knowing how to use a range object is quite important. Otherwise, you can't really manipulate anything on your spreadsheet itself. All right. So this is how I'm going to do it. I'm going to save it, and then I come here, press enter. Then I get the answer that I want. So it's a good estimate of the area under the curve, and multiply by the flow, we get the reactor width, which is 301 meter cube. So there are some extra credit questions here, for example, how to write a function with trapeziums and so on, which we probably can try by just modifying the code that you have just done. So it's actually just modifying this row, that you can get a trapezium out of the, currently we are using rectangles. All right. So this is the last example that I will show you for today. So you can see the power of a VBA in chemical engineering and how sometimes some knowledge of programming helps, not only in homework problems, but in real life. So in this case, the problems that are shown are used in real life, but are also very useful when you're doing your homework or assignments when it comes to your classes. But I will leave you with a last challenge question, which is in the worksheet as well. To calculate the enthalpy of any substance using the same constants A, B, and C. And the question is given. You also multiply A, T minus 298 plus B over 2, T squared minus 208 squared plus C over 3, T cubed minus 298 cubed. Just modify the heat capacity equation. Then you can get the enthalpy of the gas. So I think that brings us to my end of demonstration for today. The key takeaways I want to leave you guys with is, number one, you can excel in engineering with Excel VBA. Programming is not something just for computer science students. It is for engineers as well. But before you jump in programming, please make sure that we know what we want to do. Sketch out the steps one at a time. Explain them as if you are trying to tell a 3-year-old step by step what to do. That's the easiest way to describe it. The third thing is, do not overcomplicate VBA as a very difficult programming language. VBA is a basic programming language. It only has 4 components that you need to know, which are variables, operators, functions and subroutines, branching and looping. That's all you have to know. You see, even with these simple components, we already came up with so many functions to calculate energy balances, to calculate reactor sizing, to solve equations and so on, right? And the last thing is, that's all folks. Don't wait, begin your journey now. The easiest way to learn VBA is to start using it. The only way to learn VBA is to start using it. If you don't use it, forever you won't. All right. So I'm just going to just end with my email and my LinkedIn profile in case anyone wants to contact me or ask me any questions, or you want to know a solution to the problems. So I'm not going to give you a solution outright because I just want to make sure you guys actually have a look at it and actually go through it so that you gain something that is useful to yourself in your future and also currently from this session. And you are not just like listening or away from keyboard or something. So I'll just pass the floor back to the MC for today, the host for today, and Hillary. Thank you.
Yeah, thank you so much, Sir Wei Jiantio.
Wow, thank you so much, Sir Engineer, for sharing your Excel VBA skills. Personally, I felt thankful for this webinar because it adds up to my basic knowledge in Excel VBA. I realized that there are a lot of features of Excel VBA that are helpful. In addition, I am eternally grateful because I was given this opportunity that I've learned a lot, a lot of new things from you, Engineer, and that I haven't learned before. So thank you, Engineer. How about you, partner?
I also feel the same way, Math. I'm currently taking up chemical reactions engineering, sir. So this will be helpful to me and my colleagues. So this is why I am truly honored for all of us here to have you this afternoon, Engineer. Thank you very much. Now let's move on to our question and answer portion. Are you ready, sir?
Are you
The
ready?
guidelines for the question and answer would be as follows.
Okay.
For our participants here in our Zoom meeting, you can either use the raised hand feature, and when recognized, please unmute yourself so you can ask your questions directly to our speaker. You may also send your question to either me or my partner Math via private message so we can relay it to our speaker, Engineer Wei. So are there any questions?
So, all right, I'm seeing some questions in our Slido links, Engineer. So if you don't mind, Engineer Wei, I will now begin with the first one. Wait, let me see the first question in the Slido link.
Yes. So
wait for a while, I'm checking the.
Here, I found one, Math, actually.
Okay, partner. Go on.
So, sir, are there any hubs that we can use for pre-made VBA programs?
Thank you, Ray. That's a good question. Are there any pre-made Excel VBA files that we can use and so on? The fact is that VBA is not that common as Python or C something. So when it comes to free VBA programs or files, it is less common. However, if you are willing to pay, there are actually a lot of paid versions of files. There are files that can calculate the properties of steam. There are files that can calculate the thermodynamic properties of gases using equations of states. Some can even calculate solution thermodynamics. Whatever you name it can be calculated. But VBA itself is not that common when it comes to chemical engineering. So as of now, so there are quite a few, not so many free files that are available on the internet. There are some sources that I could suggest, which are Stack Overflow, STACK, and then Overflow, which is a community forum for people asking questions. Sometimes if you want to do something, for example, I want to solve the equation with a certain method, you can Google it, and then the whole solution, you can get it from Stack Overflow. So, well, if someone has done it, why do you have to do it again, right? Just use it.
Yeah.
So and maybe another good resource would be actually GitHub or GitHub, GitHub, which has some free files as well. But I would say that having free things for VBA are not that common as compared to Python or C++. Yeah, that's my answer there.
So guys, if you need some help, maybe you can contact some quote-unquote programmers so they can help you with your problems that involves VBA VBA. So for our next question, Matt.
The next question, Engineer, is machine learning possible in Excel VBA? Am I audible?
Yes.
Yeah, thank you, Larry. Oh, that's a very hot question nowadays. Everyone's talking about data science, machine learning, AI, and so on. So probably we have some AI enthusiasts in the call today. The simple answer is yes, but I wouldn't do it in Excel VBA for the simple reason that machine learning can be done easier when using